Hello, and today we will be talking about the definition of power series, the definition of interval of convergences, the definition of ratio tests, and shown 3 examples of the power series being done with finding the radius of convergence as well as testing the endpoints for the divergence test. So to start off, we have the summation as n equals 0 of the coefficient of x minus a to the nth power. Now, the next thing to talk about is that it doesn't really necessarily matter what the coefficient is. This is just the basic understanding and what's going to be utilized for every single example being shown in every power series. The next thing to understand is the radius of convergence. Now to understand this, when the x minus a is less than r and a minus r is less than x or less than a plus r, then your series is going to converge. However, just the opposite. When x minus a is greater than r, and as you can see below, x is less than a minus r, and x is greater than a plus r, the series diverges. Which is pretty much very easy to determine when you know what your a value is. It gives you your radius pretty much right away. However, finally, the inconclusive is when x minus a is equal to r, or x is equal to a. It means it could be either. So, jumping into our first problem. So before I will jump into the endpoints, interval of convergence towards the end. So to start off, our problem is the summation of n equals 1 of -1 to the n times n over 4n times x plus 3 to the n, which converges at -3, which you can figure out because if you know a being 3, you know that your x value is -3 to make the system 0. Therefore, converges at -3. So, to start to solve this problem, you would do the limit. So you want to switch your summation to limit as n approaches infinity. And then everywhere that you see an n value, you need to add a 1. So as you can see here, -1 n plus 1, the original n up there, to n plus 1, x plus 3 to the n plus 1, just like so. And these have to be within absolute values. So the next step is to take the original values or equation that you had, and you want to multiply it as a reciprocal to what you had just gotten the n plus 1s. Now in doing so, this is going to allow you to make your problem a lot easier. This allows you to then say, okay, 4 to the n plus 1 is like saying 4 times n times 4 to the 1. So when you do that, you can then cancel out some of the values, leaving you with just this right here, which is going to be negative times n plus 1, x plus 3, 4n, which you can obviously see there's an n plus 1 up here, there's not one down here, there's an n down here, there's no n down there, and you got the 4 from obviously the 4 to the 1 because it didn't get canceled, leaving you with 4n. Next on, you have L equals, and you can actually pull out, because there's no n values involved, you can pull out the absolute value of the x plus 3, leaving you with the limit as n approaches infinity, n plus 1 over 4n, which is going to simplify your problem a lot, because this then allows you to say, okay, so as a definition of intervals, interval of convergence, you need to know that when the limit is less than 1, it's going to converge. When limit is greater than 1, it diverges, and when L is equal to 1, it's either, which relates back to the beginning point that we had. So then you can solve this problem to go, okay, plug in infinity for n, you get 1/4. So 1/4 of the absolute value of x plus 3. taking this, you need to figure out where it converges and diverges. You then switch it to be both. So you have the L is less than 1, it converges. You take your limit that you had from the original, you have the 1/4 x plus 3, do the same thing for divergence. And then what you do is you're going to multiply the 1/4 over, that gives you 4. X plus 3 is less than 4, it's going to converge. X plus 3 is greater than 4, diverges. So your radius of convergence is going to be 4. So as this can be shown, -4 is less than x plus 3, which is less than 4. Move the 3 out, get it to both sides. Becomes -7 is less than x, which is less than 1. Moving on. So now we need to test the endpoints. So when x equals -7, which you got back from the other side, and you plug it into the original equation, the original -1n over 4n times x plus 3 to the n. Wherever you see an x, you're going to plug in your value that you're testing. So we're going to test the -7 in here, which if you add -7 to the 3 we had originally, it's -4. Okay, and then you're going to move over here. And to make this a little bit easier, I broke it into 2 separate parts. So you can cancel the 4n's. That leaves you with -1n, which you can do. It's to make it easier and simplify. Then you need to know what -1n times the -1n is. So over here, -1n times -1n is equal to -1 to the 2n, which again is equal to just 1. So then down below, you're going to jump down to n, or summation of n equals 1 of just n. So limit as n approaches infinity, n is equal to infinity, which means it can't be 0, so it diverges. When x is equal to -1, the summation of n to the equals 1, plug in 1 again. Remember we had plus 3 for the original, so 1 plus 3 is 4. Then you come over here. Then that's going to leave you with, you're going to be able to cancel these two, so leaving you with -1n to the times n. And then as you go down here, you're going to plug in your infinity, which is going to leave you with does not exist, which then means it diverges because you have no value. So it does not converge from -7, which is less than x, which is less than 1. I just did DNC to make it abbreviated and easier. Moving on to problem number 2. So again, we're going to start with our nice power series problem that we saw originally in the beginning. As n is equal to 1, summation of infinity, 2 to the n over n, times 4x minus 8 to the n. So breaking it back down again, you're going to switch it to limit of the absolute value. Oop, I forgot an absolute value there. My apologies. There we go. So once you have this, you need to do the adding 1 again to your original equation. So negate this part for a minute. You're going to have the 2 to the n plus 1, 4x minus 8 to the n, 1 over n plus 1. Times it by your original reciprocal again. So as you can see, the n becomes top because it was the whole thing was being divided over this. Then what you're going to do is you're going to move down here, and as you can see, I simplified it again, canceled out things that could be canceled. So that leaves you with 2n times 4x minus 8 over n plus 1. Because obviously, again, these will cancel because you have 4x minus 8 to the n, and then 4x, so those became canceled, and then the one that's to the first power gets dropped again. Same thing with the 2n's as well. So as we move down here, you then again have the absolute value of 4x minus 8 times the limit of n as it's approaching infinity of 2n over n plus 1. Again, you had to pull this out because this does not have to obtain to your n's. When you do this, that's going to leave you with 2 times the absolute value of 4x minus 8. Because if you plug that in, you will just get 2. Infinity into that. So then you come down here, remembering that if it's less than 1, it converges. If it's greater than 1, it diverges. So again, just trying to show that there. Then what you're going to do is you're going to try to just get the x all by itself. So by pulling out the 4, by simplifying the inner part, you get 8 on the outside. And when you do this, if you translate both of them, it's just going to be saying it's less than 1/8 or it's greater than 1/8. This meaning it's, obviously converging, again, from up here, or diverging, shown here. That means that your radius of convergence is 1/8. So then we got to move down here. So we get negative 1/8 is less than x minus 2, which is less than 1/8. So by getting the 2 out of there and getting the x just by itself, you have 15 over 8 is less than x, which is less than 17 over 8. Now we're going to test the endpoints again. So summation of n equals 1 of this equation. The only difference is I plugged in the 15 over 8 where the x value was. Minus 8 over n is equal to this. So, just simplify 15 over 2 minus 8 into negative 1/2. And that's how you get that. And then as you come down here, you can obviously see I just broke it in, so it made it look a little bit nicer. And I distributed the ends from the half. And then you take the values that cancel, leaving you with negative 1 to the n over n. When you plug in the value of 1 that you have for this, that's going to lead you to a convergent value because it's going to be less than 1. So moving on, we have 17 over 8, n equals 1, summation. Obviously, again, just plug in the 17 over 2. You follow the same steps in the sense that you're going to get a half this time, distribute the n again. It's going to leave you with just 1 on top because 1 to the n, just 1. Which is then eventually going to leave you to 1 over n, and as n equals 1, it diverges. So now because it equals 1 and we know it diverges, it's actually going to switch, so it's going to look like this. So 15 over 8 is less than or equal to x, because of up here, which is less than 17 over 8. So this is your interval of convergence, as well as your testing for the endpoints. And finally, we jump into the last problem here. Summation of n equals 0, and you have x to the n over 3 to the n. Now, this problem might seem a little bit easier, which it kind of is, but it's interesting because it's just the values that you get. So again, switching the summation to limit as n approaches infinity. So in this one, I actually took the absolute values and I placed it just along the x, which is possible as well. It's still the same thing as putting it around the entire thing. It makes no difference. So in doing so, I multiplied it again, n plus 1, always remember the plus 1s, and then times it by its original reciprocal. So the 3n absolute value x over n. Again, you're going to be able to cancel the values of the x to the n's and the 3 to the n's. That leaves you with limit as n approaches infinity of absolute value x to the 3. In doing so, repeating again, if it's less than 1, it converges. If it's greater than 1, it diverges. So as you can see here, just trying to get the x, the absolute value x all by itself, you get 3, or negative 3 is less than x, which is less than 3. And it diverges from x is less than negative 3 or x is greater than 3. Now, we are going to test these points again, negative 3 and 3. When taking 3, when at x equals 3, going back to the original thing again, the original problem that we had up here, the power series problem, you then are going to plug in again the 3 for the x value. This is going to give you 3n over 3n. When you do the summation of n equals 0 and you plug that in, you're going to just get 1 plus 1 plus 1 plus 1 plus 1. That means it diverges because it is greater than 1. So yeah, it's pretty straightforward with that one. As for this one, when at x equals negative 3, you will plug in negative 3 for that x value up there. And when n equals 0, it's going to switch. So it goes from 1 to negative 1 plus 1, negative 1, and so on, and it continues. that means it's going to diverge because it is going to be less than, tricking myself up here. So that then leads to divergence as x is less than or equal to -3 and x is greater than or less than -3 as it converges from -3 is less than x, which is less than 3. So I hope you learned, as well as this is probably my professor watching this video, I hope this was an accurate representation of the power series problems, understanding the definition of it, the interval of convergence, the definition of the ratio test, and the endpoints testing as well. So yeah, I hope that was helpful, and thanks for watching.